Sorry, our next speaker is David Dilks from Limnotech Incorporated here in Ann Arbor. He's vice president. He's responsible for assessment of water quality issues, primarily through the development and application of mathematical models. And interesting note here is that he's been involved as a technical reviewer and in other ways in over 200 TMDLs. In the United States, TMDL is a total maximum daily load program trying to control the amount of pollutants going into impaired water. So, David, why don't you come up next? Here we go.
Thank you, Don. And yes, you will be hearing about total maximum daily loads over the next 20 minutes. We're going to step away from the great level of detail Professor Tao gave and look at a much more general look. I'm going to be talking about 100 years of water pollution control regulations in the United States, covering the whole country and all pollutants. So 20 minutes, you're going to get a lot of coverage at not too much detail. Outline, I'll start out describing federal pollution control regulations, the history of their development, how they've evolved, the key features of federal water pollution control regulations. I'll then talk about how they've been implemented and how that is changing over time, and then wrap up with a summary of successes, failures, and future challenges. So we'll start with the history of regulations. They go back over 100 years, back to 1899. The Rivers and Harbors Act was the first time that the federal government stepped in and exerted control over what a private individual or company could put into the water. Back then, this wasn't chemicals. This was large obstacles to shipping. You couldn't throw large pieces of mass into the water to block harbors or shipping. Not so relevant to water quality, but it set a precedent that the government could regulate what you could put in the water. So that was the basis of the regulations that followed. 1956 was the beginning of water pollution control regulations and what's called the Federal Water Pollution Control Act. This is the basis of all water pollution control regulations. I'll list a series of acts from 1956 on to the present. All of those are amendments to the Federal Water Pollution Control Act. 56, it was 1956. The first act was fairly modest, did not put any requirements in, did provide mechanisms to give fundings to municipalities, cities, and towns to invest in wastewater treatment plants. 1965, the act was amended, was called the Water Quality Act. That was the first time that water quality standards were enacted. Required levels of constituent-specific quality. We need this much oxygen, this much ammonia. You cannot exceed that to be acceptable water quality. That act also created the Federal Water Pollution Control Agency, which ultimately became what is now the Environmental Protection Agency. The bulk of the regulations that control what go on in the United States today came in 1972 in the Federal Water Pollution Control Act amendments. Big thing of that is where the discharge permit program was created. At that point, based on the Clean Water Act amendments, you could not discharge from a point source into a surface water without a permit controlling the quantity and quality of what you discharged. Additional amendments came on in 1977. The Clean Water Act amendments authorized states to run the discharge program. Even though the program is federally mandated, the states are delegated. They write the permits for individual dischargers. Additional amendments in 1987, the Water Quality Act, others in 2000 looking at wet weather sources. This whole bulk of legislation is typically referred to as the Clean Water Act. Officially, it's the Federal Water Pollution Control Act. It's been amended so many times, it's now referred to as the Clean Water Act. So I'll talk just briefly about the objectives of the Clean Water Act, stated right at the preface. Primary objective, restore and maintain the chemical, physical, and biological integrity of the nation's waters. So fairly lofty goal. We want to maintain the integrity of our waters, not just chemical, also biological, also physical. Some specific goals were listed in the Clean Water Act. Much of this came from 1972 when the bulk of the legislation was written. Some interesting ones. discharge of pollutants into navigable waters will be eliminated by 1985. That's a specific objective that has not been met. Discharge of toxic pollutants in toxic amounts shall be prohibited. And a third one that I'll highlight a little more later on. I won't read the whole text, but it says that the government will develop programs to control non-point sources. So a bit of a shift between point sources, pollutant that comes out of pipes, and non-point sources that comes from runoff. The Clean Water Act says we will directly regulate what comes out of pipes. We'll eventually put programs in to regulate what comes from non-point sources, and that eventually we're still waiting for that. Just talk briefly about the key features of the Clean Water Act, the main federal regulations. Section 301 is the effluent guidelines. In 1972, when this came out, the big thing was you were not allowed to discharge into surface waters in the United States without a permit. Those permits had standards that you had to meet, and there were two levels of standards. First one is referred to as technology-based standards. Every industry has a categorization. If you're in a certain industry, there are minimum levels of treatment that you have to provide. Steel plants have their specific regulations. They're working on them for aircraft de-icing. Each industry has technology-based standards. For municipal wastewater treatment plants, the standard is what's called secondary treatment. Won't get into the environmental engineering, but you need to provide more treatment than just settling the solids out of the water. So anybody that gets a pollutant discharge permit has to meet a technology-based standard at a limit. That's the bare minimum of treatment that everyone has to provide. On top of that, you may also need to put what is called water quality-based effluent limits on top of that. You first look at the technology-based limits, do the bare minimum that everybody in your industry must do. If your discharge will cause violations of the water quality standard, you have to treat even further such that your discharge does not violate water quality standards. That more advanced level of permitting is called water quality-based effluent limits. Other key sections, Section 303, are where the state water quality standards come into play. Each state is required to publish and periodically update water quality standards. You must have numeric criteria or narrative criteria saying this is the level of water quality we need to support our designated uses, be it water supply, recreation, support of aquatic life. Section 303 also says that states need to monitor their water quality on a routine basis and determine which waters in the state are not complying with the water quality standards. That's known as the 303D list in common parlance. And if you have waters in your state that are not meeting water quality standards, states or EPA must develop what are called total maximum daily loads. If you're not meeting standards and you're putting in 100 pounds of phosphorus per day, you need to figure out whether you need to reduce it down to 90 or 80 or 60. You have to figure out the total maximum load of pollutant that your water body can assimilate and meet standards. So that's a key requirement of the Clean Water Act that's driving a lot of what is being done for implementation today. Just briefly talks about some other key sections. Section 307 was introduced in amendments about 10, 15 years ago. That's where priority pollutants such as PAHs were introduced. So originally the Clean Water Act only considered what were called conventional pollutants such as pathogens, dissolved oxygen, ammonia. The organic chemicals, the toxic pollutants, priority pollutants were added in Section 307. And then finally, in 2000, amendments spoke in more detail to wet weather pollution sources, either stormwater runoff or what are called combined sewer overflows, where municipalities treat both their stormwater and their sanitary waste in the same pipe. When rainfall events come and the amount of water coming into the pipes exceed the capacity of the treatment plant, they'll bypass that combined waste, combination of sanitary waste and stormwater without giving it treatment, and that's called a combined sewer overflow, and regulations for those were codified in Section 402. So those are the key aspects of the Clean Water Act and the basis of federal pollution control regulations. I'll talk a little bit now about the evolution of how they've been implemented. Starting in the 70s, the focus was on point source-based controls. Moving into the 80s and 90s, we moved into watershed-based controls, and then the last 10 years or so, we've looked more at biological considerations, and I'll step through that sequencing with a couple of examples. So we'll start off right after the main bulk of the Clean Water Act was passed with the 1972 amendments. At that point in time, point source pollution, pollution coming out of factories and cities coming in pipes, very bad problem, created very gross pollution sites. Clean Water Act came in and said you can't discharge without a permit, you must meet certain levels of quality. Ended up in a vast improvement in cleaning up the grossly polluted sites. And I'll give just a couple of examples of this. One of these is biological oxygen demand, organic material that breaks down in the environment and consumes oxygen. And we'll look at loading in 1968 before the Clean Water Act and loading in 1996. This is aggregate loading across the United States based on data published by EPA. And how much were coming into treatment plants in that time, it being the blue bars, and how much was being discharged into the environment being the red bars. So in 1968, there was about 17,000 metric tons of BOD being generated, about 7,000 being discharged. That meant the treatment plants were removing roughly half of the organic material that were coming into the plants, not that high of a level of treatment. After the Clean Water Act came in by 1996, population has grown, so now we're generating 26,000 pounds of BOD coming into treatment plants, only discharging 4,000 pounds. So almost a 90% removal of the organic matter coming out of treatment plants. So drastic increase in pollution control after the Clean Water Act was passed from point sources. Not just in loading, you see it in environmental response. We have a graph here of copper and clams in San Francisco Bay. Pre-Clean Water Act, very high concentrations. After point source controls were implemented, much lower levels of concentration. So grossly polluted sites where point sources were the main cause of the problem. Clean Water Act came in and it cleaned quite a few of those up. So that was the first phase of pollution control, running primarily through the 70s into the 80s. After the gross point sources were cleaned up, as states were monitoring their waters, they were still seeing there were a large number of impaired waters, even after the primary point sources had been controlled. And environmental groups were noticing the same thing starting in the 1990s, and they brought, I believe it was 38, maybe we finished up at 40 lawsuits against EPA and the individual states, saying the Clean Water Act in 1972 said you would develop these total maximum daily loads. It's 1990, you haven't done any. We don't think you're proceeding in a timely basis. And they won every single one of those lawsuits. So federal courts created mandates for states and EPA to start implementing the total maximum daily load program. The total and total maximum daily load means we're looking at both point and non-point sources. Up through 1990, in the 1990s, roughly, the focus on pollution control was on wastewater treatment plants, factories, what was coming out of pipes. As the emphasis shifted into total maximum daily loads, now regulators had to look both at point and non-point sources, not just point sources that comes in a well-defined conveyance such as a pipe, but also non-point sources originating from diffuse sources, what's running off of agricultural lands, what's running off of urban landscapes, because it was being seen that these non-point sources were causing an awful lot of, and continue to cause an awful lot of water quality problems. So the TMDLs, or total maximum daily loads, was a paradigm shift. It was a shift in the way that water pollution control was implemented in the United States in two ways. Looking at old versus new, what sources got controlled. Originally, here's my little factory icon in a watershed. We were just looking at cleaning up the factories and the wastewater treatment plants. With the total maximum daily load program and the watershed approach, we're now looking at all sources. So we're looking at farms and other sources of runoff. So we're broadening which type of sources we're looking at. We're also broadening the geographic focus. When the control was on point sources, generally the place you look was right below where the plant discharged. That's where the problems would be biggest. You try to clean that up. With the total maximum daily load watershed-based approach, we're now looking throughout the entire watershed and making sure we're complying with water quality standards. So since roughly 1990, there's been a shift in focus from just looking at point sources to considering all sources. Last 10 years or so, there's been another shift, what I'm calling biological considerations. Earlier on, the pollution controls were very parameter specific. Let's limit ammonia loading, let's control dissolved oxygen, let's control copper, which all served its purpose, but things have expanded since then. Concept that became quite popular the last 10 years is what's called whole effluent toxicity. If you operate a treatment plant now and you want a discharge permit, not only do you have to ensure that your copper concentrations are in compliance with standards and ammonia concentrations, you have to consider the cumulative effect, take a sample of your effluent, expose that to various organisms, and make sure that it's the combination of all of the parameters in your effluent are not causing toxicity. So there was a shift to biological conditions, not just looking at individual pollutants, but making sure the effluent as a whole was not toxic. From a water quality standards perspective, many states are now developing what are called biocriteria. Similar analogy to the whole effluent toxicity, we're not only worried about do we have enough oxygen, are the copper concentrations low enough, are the ammonia concentrations low enough. We want to know, do we have healthy fish? Do we have healthy bugs living on the bottom supporting a healthy ecosystem? So more holistic look, not just looking at individual pollutants, but making sure the system as a whole is acceptably healthy. So just to summarize, successes, failures, and challenges, and I'm talking about 100 years of regulations here, so we're not going to go through the whole litany of successes, failures, or challenges, but I will point out a couple, one or two of each. Big success was on point sources, certainly the first 10 or 15 years after the Clean Water Act, requiring every discharge to have a permit and controlling the quality of that permit to make sure that it did not violate water quality standards led to massive improvement at the most grossly polluted sites. So it was a very obvious improvement due to those point source controls. I think the program's moving in the right direction now in terms of taking a more holistic look. We're looking throughout the watershed, we're looking at all potential sources, runoff as opposed to point sources. We're using biocriteria. We're just not making sure we're matching a chemical number, but we're making sure that we have healthy biota in the streams and lakes. A couple of the failures. One, control of non-point sources. And I alluded to this a little bit earlier when I was talking about the Clean Water Act, where it has a pollution permit program for point sources. If you're going to have a discharge of a point source discharge into a surface water, you have to have a permit that controls the quality of it. There is no control over non-point sources. The Clean Water Act said one of the goals would be to develop a non-point source control program. That still hasn't been developed. So doing total maximum daily loads, you sometimes feel like your hands are tied. You see that a lot of the pollution is coming from non-point sources, but there's no mechanism to control them other than primarily voluntary type of control. So it has certainly stymied the implementation of the TMDL program and watershed-based controls. Maybe not one of the biggest failures, but one that's been in the news a lot lately is nutrient assessment. Back in 2000, the Environmental Protection Agency issued a directive telling states you must develop numeric criteria to protect against eutrophication and nutrient problems. Nutrients are a little trickier than other pollutants where you can just say we need a dissolved oxygen of 5 milligrams per liter. Nutrients are not that easy. The acceptable level of nutrients will vary greatly by site. If you're in a stream that has a lot of shade over you, or if you're in a stained water that doesn't have light penetration, you can assimilate a lot higher concentration of nutrients without problems than if you're in a clear water, non-shaded stream. So it's not easy to come up with numeric criteria. If you want to link the nutrients to how much algae grow to the environmental endpoint, something you can do on a site-specific basis with a lot of data, but it's more difficult to do across the country as a whole. So from a regulatory standpoint, we're seeing a dilemma right now. One option is, since we've gone 11 years with a mandate to develop nutrient criteria, next to no one's done it, What EPA is doing now is promulgating nutrient criteria, ignoring these site-specific effects. They, at the beginning of the year, passed the federal act that mandated water quality criteria for the state of Florida. Here is your nitrogen concentrate, maximum allowable nitrogen concentration. Here's your maximum allowable phosphorus concentration. Regardless of whether you can assimilate more or less, we want to have criteria. We're mandating these. So at a very coarse level of science, states are saying that's too coarse, we don't want to do it. Florida has sued EPA saying we're not going to implement these. We want to develop more rigorous linkages. And the dilemma is, do we wait for the good science and wait maybe another 10 or 20 years before nutrient criteria are developed, or do we settle for coarser science and get something on the books now? So that's a challenge that we're seeing in the water pollution control field over the near term. Challenges, a lot of challenges I could list. The one I'm going to focus on is sustainability, tying into this conference. As the population grows, it's going to further tax water resources. I had put that bar chart up of the reduction of biochemical oxygen demand between 1968 and 1996, and that roughly corresponded to, we had very high concentrations, we passed the Clean Water Act, and we got much lower concentrations. We saw that the influent load into the treatment plants was increasing due to population growth. EPA has forecasted further population growth, and as we continue on to 2020, we're going to see, although we made all of those gains in reducing oxygen-demanding loads, as the population grows, the treatment technology is sort of plateaued. We're getting that 90% removal just about everywhere, so now any more increase in population growth is going to lead into an increase in load. So the regulations are very good, or not, regulations serve their purpose in controlling known current situations and historical contaminations. They're not very good looking forward at sustainability and how we're going to address this issue. Certainly the zero discharge that John talked about in the previous session was an original goal of the Clean Water Act. We sort of got away from it. It's looking to be viable in certain cases. City of Detroit wastewater treatment plant that's putting out 1 billion gallons a day of effluent. That's not going to be quite so feasible to get to a zero discharge level. So there's certainly many challenges. And I'll leave it at that.
Thank you. Any questions for John? Or Dave, I'm sorry.
Or John, if you...
Or John.
Or neither.
Well, I've one.
All right.
Given the successes and failures, if you were to give the United States a letter grade right now on how we're doing relative to what we were doing before or where we ought to be now, what would it be?
B minus.
B minus.
I mean, certainly there's been a lot of improvement and it's trending in the right direction, but there's still a lot more to do. Certainly above a C, because most of the problems we're dealing with are not nearly as severe as there were back when I started in the late 70s, early 80s. So you're certainly seeing progress, but you're also seeing there's a lot more to go.